Hello, my name is Jan Szczegorzewski, and I'm from the König Lab and the Humboldt University. We are interested in liver function, and we use physiological-based pharmacokinetic models to tackle the problem. For this, we obviously need data, and the data come from publications. And this is basically how the project started. And now we are calling it PKDB. It's a pharmacokinetic database for individualized and stratified computational modeling. I'm very excited to present it because I've been working on it for the last 2 years, roundabout. So let me start with a introduction. Like most of the physiological pharmacokinetic publications share a common structure. First of all, they describe characteristica of studied groups or individuals. Then they report the interventions made on the individuals, and then they report the time course data, or from these time courses, calculated pharmacokinetic parameters. And that's basically what you see on the left side of my poster. On the bottom, you can also click on the 2 links. The first one is the link to a website where you can browse through through this example study. And on the download link gives you some tabular data, how you can use the data for your own interest. Okay, in the middle of the presentation, you can see a little bit the structure of the database and the content. We have a curation workflow where we take data from publications and raw data, upload it to PKDB, and you can interact with the data either via a REST API or the web interface. So we did this process for now about 700 studies. And you can see in the middle on the right picture that the data is very heterogeneous. You have sometimes a lot of time courses are reported, sometimes only the pharmacokinetic data is reported, and the database is harmonizing the data into a common structure, common units, and so on. So what are the features? We have, we represent experimental errors and variation. Everything is normalized. We have a simple curation workflow, strong validation rules, REST API, and we also show correlations between different output data. Finally, I would like to show you a little use case. We pull together data from publications reporting caffeine pharmacokinetics, and here on the right you can see the caffeine clearance depending on caffeine dose. And we also curated the smoking status and the oral contraceptive use, and you can see that the caffeine clearance is higher in individuals smoking and lower in individuals taking oral contraceptives, and this is consistent of a broad range of different publications. There are many more applications, but I would like to stop here. Thank you for your attention. And if you have any more questions, I'm very happy if you contact me.